a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest part that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. Trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed out. Total set. sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. ghost inside the machine. The coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed out. Total set. flicker in the corner of my sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. on a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed house. Total set. the corner of my sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive. a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed House. Total set. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadows grow. sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive. Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadow now. Total set. flicker in the corner of my sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadow now. Total set. silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive. Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadow down. Total set. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. Trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadow now. Total set. silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive. Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed out. Total set. sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. up on a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive. Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed out. Total set. flicker in the corner of my sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest part that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed out. Total set. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadows grow. a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive. Help me to survive. my sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed house. Total set. sight. Another phantom bleeding into white. I'm tracing lines that weren't there before. A hollow knock upon a silicone door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadows grow.
So I want you to imagine something. You go out and you hire a genius coder, like an absolute savant.
Okay, I'm picturing it.
Right. So they have read basically every technical manual ever written. They've memorized every programming language, and they can write these flawless algorithms in, milliseconds.
Sounds like a pretty expensive hire.
Oh, incredibly.
Mm.
So you bring this genius in your company, you sit them down at a computer, and you ask them to fix just a really simple bug in the login screen.
Just a standard everyday task.
Exactly. And then you watch them work. But the thing is, they don't actually write code.
Wait, they don't write code.
No. Instead, you watch this absolute genius spend like 81% of their time just randomly opening and closing empty folders on the desktop.
Just clicking around, completely lost.
Yeah, exactly. Welcome to the deep dive. Today, we're looking at why the smartest AI models on Earth are, completely lost in your code base, and how solving that specific problem is fundamentally breaking the way software is built.
It's really a profound realization when you step back and look at it. I mean, we've spent the last few years completely obsessed with making AI smarter, right?
Right. The whole race for AGI.
Yeah, we wanted higher IQ models, better reasoning capabilities, flawless syntax generation. But if you look at the actual trenches of enterprise software development right now, none of that matters.
It doesn't know where it is.
Exactly. The intelligence of the model is completely irrelevant if it just doesn't know where to look.
And that is exactly what we are unpacking today for you. We've got a stack of 3 recent dispatches from really the bleeding edge of AI software engineering.
Some really fascinating sources today.
Yeah, and taken together, these sources prove that we are rapidly moving past the era of the AI co-pilot. That helpful little autocomplete chatbot sitting next to your code.
Right, the assistant phase.
Exactly. And we are fully entering the era of autonomous AI swarms.
Which, I mean, that requires an entirely different way of thinking about digital infrastructure.
It really does. So to get us there, we're going to look at 3 things. First, a study from the Causal Dynamics lab on a tool called Solara Code.
That one is a huge wake-up call.
It really is, yeah. It reveals what AI agents actually spend their compute time doing. Then, second, we have news of a massive $200 million funding round for a startup called Blitzy.
And Blitzy is just operating on another level.
Right, they're a platform that doesn't deploy one agent, but 10,000 agents at once.
Which is just a staggering number to even think about.
Yeah, it breaks your brain a little. And then third, we're looking at OpenAI's quiet release of an open source specification called Symphony.
The workflow killer.
Yep, it takes the human completely out of the workflow dispatch loop.
And as we go through this, I really want you, the listener, to hold on to a core thesis here.
What's the main takeaway they should keep in mind?
Well, these sources demonstrate that the real bottleneck in AI development right now isn't the technology's capability to write software.
Right, it's not the coding itself.
No, the models are plenty smart. The bottleneck is how these models navigate complex information. And honestly, even more surprisingly, the ultimate bottleneck is us.
Us. Like human beings.
Yeah, it's the human attention span. That's the real limit right now.
I want to dig into that immediately, but before we can even begin to conceptualize what happens when a company unleashes 10,000 agents at the same time.
Which sounds chaotic.
Utterly chaotic. But we need to understand why a single solitary agent struggles so much first.
Right, the baseline problem.
Yeah. If giving an AI a task is like dropping it into a maze, we need to look at why it keeps hitting dead ends. So let's start with our first source, that Causal Dynamics lab study on Solara Code.
The whole wandering agent problem.
Exactly. Let's talk about the wandering agent.
So this study is, it's a complete wake-up call for the industry because it finally puts hard empirical data behind a frustration that basically every developer has been feeling lately.
Because everyone feels like the AI is getting dumber, right?
Yeah, exactly. People think the models are degrading. So the lab analyzed thousands of AI coding sessions. They wanted to know, on a purely mechanical level, what these agents are actually doing when you hand them a prompt.
Right. And you would assume, naturally, that an AI coding agent is, spending its time coding.
That would be the logical assumption.
Yeah, that it's analyzing logic, typing out solutions. But the study found that they spend less than 1% of their time actually making code edits. Less
than 1%. I mean, it is an incredibly sobering statistic when you look at the compute costs.
It's wild. Instead, 56.8% of their actions are spent just reading files.
Just scanning text.
Yeah, and another 24.2% are spent running what are called grub searches. So you add that up, And over 81% of an AI's time and all the expensive compute power associated with it is just spent looking for the right file.
Let's actually pause there and explain the mechanics of what the AI is doing, because understanding the how and why is really crucial here.
Yeah, what exactly is a grep search for the non-developers listening?
Right, so when we say an AI is running a grep search, grep is a command line utility used in Unix and Linux systems. It stands for Global Regular Expression Print.
Okay, but in plain English.
In plain English, it just means searching through massive sets of plain text data for specific strings of characters.
Oh, so it's basically like hitting Command F on a massive scale.
Exactly like hitting Command F. But imagine hitting Command F across thousands of different documents simultaneously, looking for, say, a specific variable name.
That sounds incredibly inefficient.
It is. And the AI is doing this because of how it perceives the environment. When you drop an AI agent into a modern repository, you are essentially dropping it into a massive, sprawling city. But its vision is entirely restricted to whatever fits in its context window.
Okay, wait, I want to make sure we don't just throw terms like context window around without defining them.
Fair point.
Can you break that down for the listener? Why does the context window force the AI to rely on these flat text searches?
Sure. So a context window is essentially the AI's short-term memory. It's the maximum amount of text it can hold in its brain, so to speak, at any one given second.
Okay, so it has a hard limit on what it can look at.
Right. And current language models process information sequentially. They read text from top to bottom, token by token. So if a code base has 1 million lines of code spread across 5,000 files, the AI cannot comprehend that as a holistic structure.
Can't zoom out.
Exactly. It reads code the way you and I read a novel.
But code isn't a novel. It's a machine.
Precisely. That's the perfect way to put it. In a novel, Chapter 3 logically follows Chapter 2. But in software, a function defined in a file on the front end might instantly trigger a database query written in an entirely different language in a file buried 10 layers deep on the back end.
So it's totally nonlinear.
Completely nonlinear. So when the AI uses a grep search, it's essentially standing in a library, pulling books off the shelf one by one, flipping through the pages looking for a specific keyword, putting the book back, and grabbing another.
Which brings me to this analogy I've been thinking about while reading this source. The way we currently treat AI agents is basically like hiring a master carpenter, right?
Okay, I like where this is going.
So this person has the capability to build exquisite, mathematically perfect furniture. But you blindfold them, drop them into a sprawling 1 million square foot mansion, and ask them to fix a leaky pipe in the 3rd floor guest bathroom.
Wow, that is a remarkably accurate visualization of the operational reality right now.
Right, because they aren't struggling to fix the pipe. They have all the necessary skills to fix the pipe. But because they are blindfolded, they're spending 81% of their time just feeling the wall.
Just stumbling down hallways.
Exactly.
Yeah.
Opening closet doors, checking under beds, and trying to figure out where the bathroom even is.
And the Solara code study shows exactly where that blindfolded carpenter completely breaks down.
Where do they hit the wall?
According to the text, when an AI agent is given a bug fix that requires editing more than 6 files, the agent's reliability plummets dramatically.
Wait, I need to stop you there. 6 files.
Just 6.
6 files is nothing in modern enterprise software. I mean, a single button click on a website might touch a front-end component file, a state management file, an API routing file, an authentication middleware file, a back-end controller, and a database schema.
Yeah, that's 6 right there just to log in.
Exactly.
And that is exactly why the failure rate is so high. Because the AI is blindfolded, it has to hold the state of all 6 of those files in its short-term memory, its context window.
And it just runs out of space.
Pretty much. As it wanders from file to file, searching for connections, that context window fills up with irrelevant noise. The AI starts to literally forget what it saw in file number 1 by the time it reaches file number 6.
Oh, wow.
The complexity simply overwhelms its working memory.
And here's the truly painful part for anyone footing the cloud computing bill. The study notes that these failed attempts to fix bugs across more than 6 files burn 4 times the compute power of successful ones.
Because the AI spirals.
It panics.
Essentially, yes. It realizes it made a mistake, so it runs another grep search. It pulls up 5 wrong files. It tries to patch the code based on the wrong files, breaks a test, reads the error log, gets confused, and runs another grep search.
It's just a doom loop.
Exactly. It enters a hallucination loop, just burning expensive API tokens every second until the system eventually times out.
Just burning money on servers because the AI is wandering around opening the wrong doors.
Right.
But the cost of this chaos isn't just a high AWS bill, right? It actually damages the final product.
It absolutely degrades the software quality.
Yeah, the source brings in a metric from the DORA report. And for anyone outside of DevOps listening, the DORA report is essentially the gold standard benchmark for how well software teams perform.
It's the ultimate report card.
Right. And the DORA report found that the use of these AI coding tools was actually associated with a 7.2% drop in deployment stability.
That is a stunning regression. I mean, the entire philosophical underpinning of DevOps, things like continuous integration, continuous deployment, all of that is designed to increase stability.
To make sure things don't break.
Right. We spent the last decade building pipelines to make sure code doesn't crash. And now AI tools are reversing that trend.
You are generating more code incredibly fast, but your app is crashing more often. And the article brings up this fantastic term coined by Werner Vogels, the Chief Technology Officer at Amazon Web Services. He calls this phenomenon dynamic verification debt.
Dynamic verification debt. We really need to unpack that because it is the defining engineering crisis of this exact moment in time.
How is it different from normal technical debt?
Well, historically we had technical debt, right? Which is when engineers write messy code to hit a deadline, knowing they will have to clean it up later.
Like using duct tape on a pipe instead of actually replacing it.
Exactly. But dynamic verification debt is much more insidious. It is the dangerous, rapidly growing gap between how fast you can generate code using an AI and how well the human engineering team actually understands what that code does to the rest of the system.
Because the AI generated it in 3 seconds, but it would take a human 3 hours to read it and trace all the dependencies.
Exactly. The AI is generating code so quickly that humans cannot physically verify the logical soundness of how it interacts dynamically with the rest of the architecture.
So you just end up with this bloated system.
Right, you end up with repositories filled with code that works perfectly in isolation, but the second it hits production and interacts dynamically with a live system, it shatters.
Nobody knows why.
Exactly, nobody on the team knows why because nobody actually wrote it.
Man, that's a nightmare. So how do we fix it? Because obviously, Solara looked at this wandering agent problem. They looked at this massive accumulation of dynamic verification debt, and they realized the fundamental flaw was the blindfold.
Yes. They realized that treating code as a series of flat text documents and forcing an AI to grep through them sequentially was a dead end.
So what's their alternative?
So Solara built something called a code dependency causal graph before the agent is even allowed to start working.
Okay, code dependency causal graph. That sounds incredibly heavy.
It is a mouthful.
Let's break down how that actually works under the hood. What does that mean mechanically?
It sounds dense, but think of it as a multi-dimensional, omniscient map of the entire system.
Okay.
Before Solara gives the AI a prompt, its engine parses the entire code base. It doesn't just read the text. It analyzes the abstract syntax trees, the underlying structure of the code.
Oh, so it's looking at the bones, not just the skin.
Exactly. It maps out what every function does, which variables it calls, who the original human owner of that code is, what its memory constraints are, where it gets deployed, and crucially, what happens dynamically at runtime.
So it's not just a directory. It's not just a map that says, the bathroom is down the hall.
Right.
It's a map of causality. It knows that if I touch this specific pipe in the guest bathroom, it will cause a pressure drop in the kitchen sink on the first floor.
Precisely. It maps the cause and effect of the entire architecture. So when the AI agent is deployed, it is no longer given a blank context window and forced to grep for keywords.
It is the cheat sheet.
It has the ultimate cheat sheet. The agent is handed this pre-computed causal graph. It already understands the global system architecture before it writes a single line of syntax. It navigates relationships, not text files.
And the results from giving the AI this causal map are incredible. The source highlights that by using this graph approach, localization accuracy, which that's the specific metric for how accurately an agent can pinpoint the exact place in the code that needs fixing it, jumped to 0.774.
Which is a huge leap.
Right, and just to put that in perspective for the listener, that beat Anthropic's Claude code, which scored 0.738, and it beat OpenAI's Codex, which scored 0.707.
Oh, it's beating the giants.
Exactly. And because the agent isn't stumbling around in the dark running false searches, the compute costs per task drop by 30 to 40%.
Which is massive at scale. So we need to transition into what this actually means, because this gives us a profound piece of analysis for the general tech landscape.
Yeah, where does the industry go from here?
What this Solara data tells us is that the frontier of software engineering is no longer about code generation. We have conquered generation.
Right, the typing part is solved.
The models are basically flawless at writing a Python function or a React component in isolation. The entire frontier of software engineering has shifted completely to code-based understanding.
That is such a vital distinction. It's basically the difference between knowing how to speak French perfectly and knowing the cultural context of what you were actually saying in a Parisian boardroom.
That's a great way to look at it, yeah. And you can see this shift happening across the industry landscape right now. Tools like Cursor, which is a wildly popular AI code editor, they're shifting this way by incorporating semantic search and vector indexing of the code base.
GitHub Copilot is doing this too, right?
Yeah, GitHub Copilot is moving toward mid-workflow code scanning to gather context. But the source makes a very pointed critique here. It states that most of these current mainstream tools are still essentially just, quote, fast grep with extra steps.
Fast grep with extra steps. Ouch!
Right. They are using vector databases to guess which text files are relevant, but they aren't mapping true architectural causality. Solara proves that true system mapping is the only way forward.
Which leads me to ask about the AI market itself. Because if the core LLM models, whether it's GPT-4 or Claude 3.5 Sonnet or Gemini, if they're already more than good enough at the actual syntax writing part,
They are.
does this mean the true market value, like the real unicorn level money, is shifting away from the companies building the LLMs and toward the infrastructure companies that feed them context?
Without a doubt, the balance of power is shifting entirely. Market dominance over the next 5 years will belong to whoever builds the best map, not just the best brain. You can have the highest IQ language model in the world with perfect logic and reasoning, but if it is blindfolded, it is useless in an enterprise environment.
Just bumping into walls.
Exactly. The companies that figure out how to parse, map, and graph massive, messy, decade-old enterprise code bases so that any LLM can navigate them safely, those are the companies that will capture the real enterprise value. The language model itself is rapidly becoming a commoditized engine. The map is the proprietary differentiator.
And for you, the listener, whether you are an AI user, a product manager, or an engineer building with AI agents, what this means is that your fundamental relationship with these tools has to change immediately.
It has to.
The days of treating AI like a magic 8-ball chat box where you just paste an error message, cross your fingers, and say, fix this, those days are over.
You have to shift your operational mindset. You have to assume the burden of providing structural context.
Right, you can't just expect it to know.
If your AI is failing to complete a task, if it is hallucinating variables that don't exist, or if it's fixing a bug by breaking 3 other parts of your application, you need to understand that it is very likely not a logic error on the part of the model.
It's a mapping error.
It is a mapping error. It failed because it didn't have the context of the whole system. Your job as a user is no longer to prompt for code. Your job is to curate the context.
Which is the perfect logical bridge to our second source today. Because if the Solara study proved that a single agent requires a highly detailed causal map just to fix one bug efficiently, the natural engineering impulse is to scale that up.
Of course, engineers always want to scale.
Exactly. But mapping a single repository for one agent is very different from mapping an entire legacy enterprise system. What happens when a company tries to map a 100 million line code base and unleash an absolute swarm of agents simultaneously? Let's look at Blitzy.
This is the moment where the scale of what we are talking about goes from academically impressive to industrially terrifying.
Yeah, absolutely terrifying. Let's start with the hard numbers because they are explosive. Blitzy just announced a $200 million funding round, valuing the company at $1.4 billion.
Massive numbers.
And what stands out to me isn't just the dollar amount, but who is writing the checks. This isn't just speculative Silicon Valley venture capital, right? This is backed by Northzone, Battery Ventures, PSG, and Liberty Mutual.
That last name is the signal in the noise.
Liberty Mutual.
Yeah. When players like Liberty Mutual, which is a massive, highly regulated insurance conglomerate, when they are involved in a funding round for an AI coding tool, this is targeting heavy, serious, compliance-driven enterprise environments.
This isn't for building a trendy web app.
Exactly. This is for rewriting the core systems of the global economy.
Right. And the premise of Blitzy is what makes this so wild. Blitzy doesn't exist to help a single human developer work 20% faster. They don't do the co-pilot thing.
They're way past that.
Blitzy orchestrates thousands of AI agents working in parallel. They let these agents run for days or even weeks of uninterrupted continuous inference. And their stated objective is to ship 80% of massive multi-month engineering projects without a human being writing a single line of code.
Now, if we connect this back to what we just learned from the Solaris segment, we can understand the mechanics of exactly how Blitzy makes this seemingly impossible claim a reality.
Because it does seem impossible.
It really does. Because if one agent breaks when touching 6 files, how do 10,000 agents not just instantly corrupt an entire system?
That's exactly my question. How is this not an apocalyptic merge conflict? If I have 10,000 agents all trying to push code at once, they're going to overwrite each other, break dependencies, and shatter the application in seconds.
They would if they are blindfolded. But Blitzy's secret sauce is taking that knowledge graph concept we discussed and applying it on an industrial scale. We are talking about enterprise code bases that range from 1 million to over 100 million lines of code. These are what the industry calls monorepos, massive, centralized repositories where all of a company's code lives. Blitzy takes that entire estate and reverse engineers it into a persistent, dynamic knowledge graph.
Wait, reverse engineering 100 million lines of code? Human beings cannot even comprehend that much text. It would take lifetimes. How does a system actually build a graph of that size?
It requires a massive upfront compute investment. Before a single AI agent is ever given a coding task, Blitzy's infrastructure spiders through the entire monorepo.
It just crawls everything.
Everything. It parses every single service, analyzes every API contract, traces every database schema, and maps every deployment target. It builds a mathematical representation of the entire enterprise.
And it updates.
Crucially, yes, it is dynamic. As one agent makes a change to a database schema, the knowledge graph updates in real time, instantly broadcasting that new reality to the other 9,999 agents.
So they took the Solaro approach of taking off the blindfold, but they didn't just map a house. They mapped a sprawling, chaotic metropolis and put a GPS tracker on every single brick.
Precisely. The agents in Blitzy don't wander, they don't grep, they follow a pre-built, hyper-accurate, centrally managed map. And because they share that single source of truth, Blitzy can execute what they call swarm execution.
Let's detail how that orchestration layer actually works, because this is where it stops being an AI tool and starts functioning like an automated digital factory.
It really is a factory.
You don't have one super agent trying to do everything. You have thousands of specialized agents. For instance, the human manager says, we need to migrate our user database from an old SQL server to a new cloud database.
Classic enterprise headache.
Oh, massive headache. But Blitzy takes that objective and spins up a swarm. One group of agents is exclusively assigned to refactoring the database layer. While that's happening, a second group of agents is rewriting the API endpoints so they can talk to the new database simultaneously. A third group is updating the front-end interface to handle the new data structures. And a fourth group of agents isn't writing code at all. They're just running continuous integration tests, validating the outputs of the other three groups in real time.
All running in parallel. All cross-referencing that same massive knowledge graph to ensure they don't step on each other's toes.
It's like a symphony.
It is. If the API agent tries to request a data field that the database agent hasn't built yet, the knowledge graph flags the dependency, and the API agent waits. It's a beautifully choreographed ballet of machine logic.
And the human. The human only steps in at the very end to review the architecture, ensure the business logic makes sense, and polish the final 20% of the project.
And the metrics backing this up are just as impressive. The source highlights that Blitzy achieved a record-breaking score of 66.5% on SWB Bench Pro.
For the non-engineers listening, SW Bench Pro is the software engineering benchmark. It tests an AI's ability to solve real-world GitHub issues found in major open-source projects.
Yes, and a score of 66.5% is miles ahead of any publicly known score. Most standard LLMs struggle to break 20 or 30% on these benchmarks.
So it's basically doubling the industry standard.
Easily. But what I find equally fascinating and what really explains their approach is the pedigree of the founders.
Yes. Brian Elliott and Sid Pardeshi. This is such a great detail from the source.
Brian Elliott is a former U.S. Army Ranger. Sid Pardeshi is an NVIDIA master inventor with over 27 patents, specifically in neural networks and distributed AI systems. They met while building software together at Harvard.
An Army Ranger and an NVIDIA Master Inventor. I mean, that sounds like the pitch for a tech thriller movie.
Doesn't it? But it tells you exactly how they approach the problem. As the source explicitly notes, this is not a team of theoretical AI researchers sitting in a lab trying to tweak a language model's weights to make it slightly more poetic or empathetic.
No, they're not worried about the AI's feelings.
Not at all. This is a team that thinks entirely about mission execution, logistics, and orchestration at scale. The Ranger understands how to coordinate a massive swarm to achieve a strategic objective. And the NVIDIA inventor understands the sheer hardware and network architecture required to actually process it.
And they are aiming this heavy artillery directly at the most complex, bureaucratic organizations on Earth. The source says this is built for Fortune 500s. Financial services, insurance, government contractors,
big guys.
organizations with 50 million line code bases, incredibly strict regulatory compliance, and engineering cultures that measure project timelines in fiscal quarters, not 2-week agile sprints.
Now I know what you, the listener, are thinking, and I want to address the massive, glaring pushback here.
I am extremely skeptical. I'm struggling to see how this is allowed.
It sounds risky, right?
Yeah. You were telling me that Fortune 500 banks and government agencies, institutions that are heavily audited, where a single coding error could leak millions of social security numbers or violate international financial regulations. You are telling me they're trusting their most sensitive code to an autonomous swarm of AI agents.
It sounds insane.
It sounds reckless. It sounds like an uninsurable security risk.
It absolutely sounds like a disaster waiting to happen if you view it through the lens of traditional AI usage. But the source explains exactly why these companies trust it, and it comes down to systemic validation.
Systemic validation. Meaning what? Meaning Blitzy isn't relying on one single massive god modern to make all the decisions. For a single enterprise project, Blitzy might route over 100,000 individual model calls, and it routes them dynamically across different providers.
Also, they mix and match.
Exactly. It might use Google's Gemini for deep context analysis, Anthropic's Claude for complex reasoning and safety alignment, and OpenAI's GPT-4 for syntax generation.
Ah, so it's crowdsourcing the intelligence, it's pitting the best AIs against each other. Precisely. It uses whichever model scores best for a highly specific microtask. And more importantly, the agents are constantly checking each other's work against the immutable rules of the knowledge graph.
The testing agents.
Right, quality is validated at a massive systemic scale. So these enterprise clients don't have to trust the unpredictable output of a single language model. They trust the deterministic infrastructure of the Blitzy system. The testing swarm catches the hallucinations before they ever reach human review.
This brings us to a crucial piece of analysis for the general tech landscape. What this tells us is that the timeline for the whole AI is going to replace software engineers narrative has been radically pulled forward.
It really has.
But not for the reasons everyone thought. It hasn't been pulled forward because the models suddenly became AGI. It has been pulled forward because the infrastructure and the orchestration layers around the models finally caught up to enterprise requirements.
Exactly. This proves a fundamental tectonic shift in the AI market. We are moving decisively away from single-session, human-in-the-loop tools. We are moving past the standard copilot, where a human types a prompt and waits for a function.
That's yesterday's news.
The market is moving toward complete lifecycle replacement.
The source has a brilliant analogy for this. It states that it's the difference between building a better hammer and building a fully automated factory that constructs the entire house.
Yes, and the market valuations reflect that reality. Billion-dollar checks aren't going to the companies building slightly better hammers anymore. They are going to the companies building the automated factories. The orchestration and persistent execution layers are where the massive capital is flowing.
So if you are an AI user, or more specifically, if you're a human software engineer listening to this right now, what does this mean for you? Because this sounds like an existential threat to the profession.
It is a total identity shift. Your evolving role is profound. In a Blitzy-enabled environment, you are no longer writing code. You are likely not even reviewing individual pull requests or reading syntax anymore.
So what are you doing?
The human's job is elevating entirely to defining the strategic objective.
Which sounds crazy to a developer whose entire career has been built on knowing how to write elegant syntax.
But that is the new reality. The human stands at the top of the system and says, we need to migrate this legacy SQL database to a distributed cloud-native architecture, and it must maintain these specific SOC2 security compliance standards and achieve sub 50 millisecond latency.
You just set the rules.
That is the strategy. The human sets the boundaries. The platform, the swarm of 10,000 agents, executes all the tactical mechanical steps to make that happen.
It really is marvel-inducing. The idea of humans stepping back to dictate high-level objectives, almost like a general commanding an army of digital workers. But as I think about that, it raises a very real, very mechanical, logistical problem.
The human problem.
Right. If a system could do the work of 10,000 engineers in parallel, how does a human manager even assign them tasks fast enough?
Right. How do you feed the beast?
Exactly. If the agents finish a complex task in 5 minutes, the human manager would have to sit at their desk 24 hours a day just writing new prompts to keep the swarm busy. You've suddenly created a massive bottleneck, and that bottleneck is the human manager's ability to hand out work.
And that exact logistical nightmare leads us perfectly to our third and final source. We need to look at how OpenAI themselves hit this exact wall and how they re-engineered the entire workflow of software development to solve it.
Yes. Let's talk about OpenAI Symphony and the removal of the human bottleneck. On April 27th, OpenAI quietly released an open-source specification called Symphony.
Just a quiet little industry-shattering release.
Yeah, barely made a ripple in mainstream news. To be clear on what this is, it's currently a reference implementation. The original was written in Elixir, but because it's open source, the community has already ported the spec to TypeScript, Go, Rust, Java, and Python. And the results of OpenAI using this system internally on their own engineering teams are staggering.
Staggering is almost an understatement.
The source reveals that OpenAI saw a 6x increase, a 600% increase in merged pull requests in just 3 weeks of using Symphony.
To put that in operational context for you, the listener, if your engineering team usually ships 100 features or bug fixes a month, implementing Symphony bumps that to 600 features a month.
It's absurd.
That level of velocity breaks the operational model of almost every company on Earth. Standard agile methodologies cannot comprehend 600% throughput.
It completely shatters the concept of a sprint. You can't plan a 2-week sprint when the work gets done in 2 days. So let's look at the core problem that birthed Symphony. Why did OpenAI build this?
The wall they hit.
Right? The source tells us that engineers working internally on OpenAI's Codex platform hit a hard physical ceiling. They had access to these incredibly fast AI coding agents, but a single human engineer could only physically manage about 3 to 5 parallel agent sessions at a single time.
And even managing 5 parallel sessions is cognitively exhausting.
Imagine managing 5 hyperactive genius interns who finish their work every 2 minutes and instantly ping you on Slack, needing you to review their code and tell them exactly what to do next.
Your brain would melt.
The context switching became impossible for the human brain to handle. The AI was simply too fast. The ultimate bottleneck wasn't the AI's intelligence or capability. The ultimate bottleneck was the human attention span.
The Symphony team actually explicitly wrote this in their specification document. They said, quote, "The agents were fast, but we had a system bottleneck, human attention."
That is such a profound realization.
And what is fascinating here is the brutal engineering logic of their solution. If the human is the bottleneck, you don't artificially slow down the AI to match the human's pace. You completely remove the human from the loop.
Let's detail how the Symphony workflow actually achieves this, because it fundamentally rewires how a software engineering department operates. Symphony takes the issue tracker, the ticketing system where product managers list the bugs and features to build.
Like Jira.
Exactly, like Jira. In OpenAI's case, they use Linear, but this applies to Jira or anything else. Symphony treats that issue tracker as a state machine.
Okay, let's clarify state machine for the non-engineers because this is the core mechanism of the whole system.
Please do.
A state machine is a mathematical model of computation that can be in exactly one of a finite number of states at any given time.
Sounds complicated.
In the context of an issue tracker, it's actually simple. It just means the system automatically algorithmically tracks the life cycle of a ticket as it transitions from to-do to in progress to review to merged.
Right, so instead of a human looking at the backlog of tickets and deciding which engineer gets which task, Symphony automates the dispatch.
It acts as the manager.
Symphony looks at the backlog, it reads a ticket, it autonomously assigns an AI agent to that ticket, and it isolates that agent in its own secure workspace. The human doesn't assign the work, Symphony does it. And then Symphony manages the agent entirely.
This is where the magic happens. Think about what usually requires a human's attention. If an agent crashes mid-task, a human usually has to restart it.
Right.
Symphony senses the crash and automatically respawns the agent. If the agent writes the code, but the continuous integration tests, the CI tests fail.
Let's pause on CI tests just to be crystal clear.
Continuous integration tests are automated scripts that run every time new code is submitted to make sure the new code doesn't break the existing application. Normally, if a human pushes code and the CI tests fail, the human gets an alert, reads the error log, and tries again.
But with Symphony, if the CI tests fail, it doesn't ping the human on Slack. It autonomously reads the error log, rebases the code, and tells the AI agent to retry, feeding it the error data as context.
And you mentioned rebasing. We need to explain that because it shows how sophisticated the system is.
Oh, developers hate rebasing.
They despise it. In software development, multiple people are adding code to the main branch at the same time. If Agent A takes 3 hours to finish a task, by the time it's done, Agents B, C, and D might have already added new code to the main branch.
The ground moved beneath them.
The foundation has changed entirely. Rebasing is the complex process of taking Agent A's code and carefully slipping it on top of the newly updated foundation without breaking anything. It's notoriously tricky. Symphony handles all of that rebasing autonomously.
The massive paradigm shift here is the complete removal of the human from the dispatch and coordination loop.
Yes, no more humans looking at a Kanban board during a daily stand-up meeting and saying, okay, who has bandwidth to take ticket 402?
And no more waiting for builds to finish. Before Symphony, a human developer would finish writing their code, push the commit, and then sit there staring at a loading bar waiting for the automated tests to run.
Taking a coffee break.
Maybe they go get a coffee or read Twitter. With Symphony, the system handles all dependent work in parallel. If ticket B depends on the code from ticket A, Symphony just monitors the state machine. It waits until ticket A passes its tests and is merged, and the millisecond that happens, Symphony instantly dispatches a new agent to start ticket B.
It never sleeps.
It never sleeps, it never gets distracted, it never needs a coffee break.
But, and this is highly important to note, the source does point out OpenAI's own warnings about the limitations of this system. It is not infallible magic.
Right, there are trade-offs.
Huge trade-offs. Moving to this automated ticket-level assignment means the human engineer loses something very valuable. They lose the ability to intervene in real time.
Right. When you are using a standard AI copilot in your code editor, you can watch it type. If you see it going down the wrong architectural path, you can interrupt it, delete the code, and correct its course immediately.
You're steering the car.
With Symphony, you are locked out of the kitchen while the chef is cooking. You only get to see the final dish when it's placed on the table.
And the source mentions that early internal versions of Symphony were actually too rigid to be useful. The agents were only given the ability to be truly autonomous, agents had to be given expanded tool sets to handle the periphery of software development.
Like reading logs.
Yes, they needed the ability to read the CI logs when tests failed. They needed the ability to read written review feedback from humans and interpret it. If the agents couldn't perform those peripheral tasks, the rigidity of the automated workflow made the whole system useless. The agent would just freeze.
So, looking at the general tech landscape based on this third source, what is the major takeaway? Because Symphony is open source.
What's crucial to understand is that Symphony isn't even a product. OpenAI explicitly states in the release that they do not plan to maintain it as a commercial enterprise product.
It's just a proof of concept.
It is just a reference implementation. They are basically opening their garage door and showing the world the tools they built for themselves.
But the signal it sends is earthquake level for the industry.
Absolutely earthquake level. Because it proves that the primary engineering challenge of the tech industry today is no longer, can the AI write code? The models are smart enough. The primary challenge every CTO must face is now, can your company's workflow get out of the AI's way?
This actually brings up something I was struggling with while reading the source material. Why would OpenAI open source this?
Because it seems counterintuitive.
Yeah, if Symphony gave their internal engineers a 600% boost in productivity, that is a massive competitive advantage. Why give the secret sauce away to the public for free? I was thinking about this and I realized it's a classic razor and blades model, but applied on an industrial scale.
Oh, absolutely.
It's like a massive oil company giving away the free blueprints for a giant, incredibly powerful but incredibly fuel-guzzling engine.
That is exactly what it is. The workflow is the razor, the compute is the blade.
By open sourcing the Symphony specification, OpenAI is intentionally accelerating the industry-wide shift toward these autonomous continuous systems. And what do autonomous systems need to function? They need millions and millions of API calls to language models.
They burn compute relentlessly. They run 24 hours a day, querying models, reading logs, running tests, retrying failures. And OpenAI sells the compute. They sell the API calls.
That's brilliant.
By giving away the workflow engine that removes the human bottleneck, by giving companies the tool to unleash 10,000 agents at once, they ensure that those companies will consume vast, unprecedented amounts of AI processing power, which inherently drives massive recurring revenue back to OpenAI and the other underlying model providers.
It's a brilliant, almost ruthlessly efficient business strategy. But let's bring this all the way down to the individual. For you, the listener, who might be a senior engineer or a product manager managing AI agents, what does this actually mean for your daily professional life?
It means the standard workflow of software development has changed forever. You are no longer opening a coding session, staring at a blinking cursor, and typing syntax.
You're not coding.
You are spending your time crafting highly detailed, perfectly contextualized tickets. You drop that ticket into a backlog and you walk away.
You essentially become an asynchronous reviewer.
Yes, your role shifts entirely from being a micromanager of code syntax to an asynchronous reviewer of outcomes. You are relying entirely on the system, the knowledge graphs, the swarms, the state machines, to resolve its own merge conflicts, to read its own error logs, and to eventually present you with a finished test-passing pull request. You evaluate the result, not the process.
Okay, we need to synthesize this incredible journey we've been on today, because we have covered an immense amount of ground, and the implications are staggering. We started by looking at the microscopic level. Single agents lost in the dark, burning up expensive compute power, just running grep searches.
And hallucinating because they didn't understand the causal structure of what they were looking at.
Exactly. That was the Solara code problem and the accumulation of dynamic verification debt.
The blindfolded carpenter stumbling around the mansion.
Right. We then zoomed out to see how billion-dollar enterprise companies are solving that exact problem at scale. They are building massive, persistent knowledge graphs, omniscience maps of entire 100 million line monorepos to guide swarms of 10,000 agents working in parallel.
That was glitzy, shifting us from a better hammer to an automated factory.
The industrialization of the swarm, relying on systemic validation rather than individual model intelligence.
And finally, we saw how a very workflow and logistical management of software engineering is being completely rewired. To feed that factory, we have to remove the human bottleneck entirely, allowing systems like Symphony to dispatch, manage, retry, and rebase agents autonomously based on state machine logic.
Is a complete top-to-bottom reimagining of how digital infrastructure is created, managed, and deployed.
It really is.
It really is. And to close out today's deep dive, I want to leave you, the listener, with a final provocative thought. Something to mull over as you look at the software you interact with today.
If AI agents are the ones writing the raw code,
Which they are.
and other AI agents are building the complex causal graphs and knowledge maps of that code, and yet other AI agents are using those maps to deploy swarms that build even more complex dependencies and architectural frameworks. We are rapidly approaching an ecosystem that is built by machines, expressly for machines to navigate.
Which circles all the way back to the beginning. We thought AI was just a tool to help humans write software. But it turns out AI is building an entirely new environment.
Exactly. So the real question becomes, what happens to the human objective setter? The person whose only job left is to stand at the top, point at the map, and say, go here.
Yeah, what happens to them?
What happens when the underlying architecture of the software becomes so deeply complex, so utterly alien and recursive in its machine-generated structure, that a human brain literally cannot even read the map anymore?
Wow. That is a wild, slightly unsettling thought to end on. If the map is only readable by the swarm, who is really in charge of the destination? Thank you so much for joining us for this conversation. Keep questioning the systems you use every day. Keep looking at the maps being built around you, and we will see you on the next deep dive.
You know, if you've ever been to like a major movie backlot, there's this incredible, almost jarring moment of disillusionment that happens.
Oh yeah, it's totally surreal.
Right. You're walking down what looks exactly like a bustling, gritty New York street, You walk up to this beautiful brownstone, you reach out, you open the heavy oak door.
And there's just absolutely nothing behind it.
Nothing, just like bare wooden struts, some scattered sandbags holding up a fake wall, and, the smell of fresh paint.
Because it's a complete illusion. I mean, that brownstone was engineered to look utterly perfect from exactly one angle for exactly one camera take, and not a millimeter beyond that.
Exactly, and the second you try to actually live in it, or even just lean against the wall too hard, the whole thing just collapses. Welcome to the deep dive. Today we're talking about that exact moment of collapse, but we're looking at it in the world of artificial intelligence.
Which is incredibly timely.
It really is. We have a fantastic stack of sources for you today. We're pulling from 3 really insightful articles that were just published on May 8th, 2026 by the tech publication n0brains. And our mission for this deep dive is to track a massive tectonic pivot happening right now across the entire tech industry.
Yeah, we are pinpointing the exact moment the landscape shifts from the era of the magical demo to, well, the era of the hardened system.
And whether you realize it or not, this shift directly impacts you. Whether you're a developer actively building AI or, an executive deploying it, or just a consumer trying to understand where the software market is actually heading.
Because the very definition of what makes an AI system valuable has just fundamentally changed over the last year. Raw intelligence. It's no longer the differentiator. Execution, infrastructure, control, those are the new gold standard.
Okay, let's unpack this, starting with the first article from our sources. It has this wonderfully ominous title, The 6-Week Deadline for Shipping AI. And it opens with this brutal reality check about what they call the demo trap.
Oh, the demo trap. We have all seen this play out.
So many times.
Yeah.
An engineer fires up a Jupyter notebook, which, for those who might not code every day, is basically a digital scratch pad. Data scientists write little blocks of code and see immediate results. So they get a foundational model working perfectly in that controlled bubble.
Right.
They wrap it in a Gradio app, basically just a drag and drop tool to slap a shiny web interface onto the code, and they take it into the boardroom. They type in a query, the AI gives this brilliant answer, and the executive's jaws just hit the floor.
And that is exactly where the trap springs.
Right.
Because the executives see that brilliance and they immediately assume, oh, the product is 99% finished.
Yeah, we're basically ready to ship.
Exactly. They think the hard part, the actual intelligence is solved. So deployment should be trivial.
But then it hits a real user in the wild, and the whole facade shatters. The source highlights 3 specific failure modes that just absolutely destroy these demos in production. First, you get latency spikes.
Right, because a demo is just one person testing it.
Exactly. When the CEO tested it, it was lightning fast. But when 10,000 users test it, the GPUs get totally choked. Suddenly, that snappy customer service chatbot is taking like 20 seconds to generate a single sentence.
Which is an eternity for a user.
It is. And second, you have these trust-burning hallucinations. The AI gets confused by some weird edge case customer prompt and confidently makes up a refund policy, and now your company has to actually honor it.
Yeah, legally, that's a nightmare.
Huge nightmare. And third, the inference costs. Just the raw compute power required to generate these answers will eat the entire project budget alive within a week.
And to understand why that happens, you really have to look at how the barrier to entry for large language models has completely inverted traditional software engineering.
How do you mean?
Well, think about the past. Getting a prototype to do something even slightly smart took years of machine learning research. Years. Today, it has literally never been easier to build a prototype.
Yeah.
You can ping an API from a frontier model and get a staggering human-level response in, an hour?
Yeah, an hour tops.
But the article lays out this hard, almost terrifying metric for developers. While the prototype takes an hour, it takes months of grueling infrastructure work to build a system that consistently returns the correct answer in under 500 milliseconds.
For a fraction of a cent.
Right, under 500 milliseconds for a fraction of a cent. That is the new bar.
Half a second. That is the barrier between a toy and a viable commercial tool. And honestly, reading that made me realize how we've essentially been treating AI development up until now. It's basically been like vibe checking.
Vibe checking, I love that.
It's true though. You sit at your keyboard, you tweak the prompt, you add a please or take a deep breath and think step by step, and you test it 5 or 6 times until it just feels right. But wait, if the smartest foundational models are becoming these cheap, easily accessible commodities, and the real work is just caching queries and routing server traffic, isn't the magic of AI basically gone?
What's fascinating here is that the magic isn't gone at all. It's just maturing. It's maturing into a rigorous engineering discipline.
Okay, I'm listening.
Think about the early days of aviation. The Wright brothers taking off a Kitty Hawk, that was pure, unadulterated magic to anyone watching.
Sure.
But commercial aviation today, that isn't magic. It's aerodynamics, it's redundant hydraulics, air traffic control protocols, intense maintenance schedules. That is exactly where AI is right now.
Ah, I see.
And the source highlights this specific 6-week gap. That is the aggressive make-or-break timeline the industry has settled on between having that working prototype and actually deploying a scalable production-grade LLM system.
So you basically have 6 weeks to figure out if you've built a real house or just a movie set facade.
Exactly that. And the industry impact of this realization is profound. The market is sending a deafening signal right now. The value has shifted entirely away from the models themselves and into the application layer.
Because everyone has access to the models now.
Right. Fortune 500 companies do not want to buy another chatbot demo. They want the unglamorous heavy lifting. They want semantic caching, so they don't pay the AI to generate the exact same answer to a common question twice.
Makes total sense.
They want robust guardrails to prevent the AI from accidentally discussing a competitor's product. They want full observability and automated evaluation loops so they can actually measure performance quantitatively.
It's an ultimatum.
It is. The ultimatum laid out in the source is stark prototypes are now seen as liabilities. Production systems are the only real assets.
It's a total adapt or die moment. Like, the hobbyists get to explore the frontier, but the professionals have to ship the plumbing.
Precisely.
Which naturally makes you wonder about how we actually give instructions to these hardened systems. Because if the industry is now demanding rigorous, scalable infrastructure instead of these vibe-check demos, then we clearly can't rely on human intuition to manually type out the rules for these models.
Oh, we really can't. We've reached the absolute limit of what human foresight can manage when it comes to controlling non-deterministic systems.
And that leads us perfectly to the second article from n0brains, which is titled The End of Prompt Engineering. And it details how manual prompt engineering, typing out paragraphs of instructions to guide the AI, is really just a glorified form of trial and error debugging.
We've been treating prompts like magical spells.
Exactly. But the source points out that when you move from a simple conversational chatbot to a multi-tool agent, meaning an AI that can browse the live web, query a secure database, and send an email on your behalf, you trigger this massive combinatorial explosion of possible paths the AI can take.
Because an agent isn't just retrieving information to answer a question anymore, it's taking sequential, autonomous actions based on its own internal reasoning loop.
Right. It observes an outcome, decides the next step, and executes a tool.
And if your carefully typed prompt has one tiny missing instruction for a weird edge case,
it triggers a disaster. The agent might get stuck in an infinite loop where it just keeps calling the same search tool over and over, burning through your API budget every second. Or worse, it leaks sensitive internal data into a public web search. It's like a cosmic, high-stakes game of whack-a-mole.
whack-a-mole is the perfect way to describe it.
Right. You realize the AI is using too many emojis, so you fix that edge case in your prompt. But by changing those words, you accidentally break 3 other things, and suddenly the agent forgets how to format a basic data table.
Handcrafting prompts for a complex, autonomous agent is just a mathematically losing game. A human being simply cannot map out every single edge case, every possible user input, every potential tool failure. The language space is just too vast.
Here's where it gets really interesting, because to solve this, the source introduces a new framework called Adelflow. And Adelflow fundamentally flips how we handle giving instructions to AI. Instead of a human writer endlessly tweaking the adjectives in a prompt, Adelflow treats the text of the prompt itself like model parameters.
Yeah, this is a huge shift.
But the article dives into some pretty heavy terminology here. It says, Adelflow uses, quote, retriever augmented loss functions and discrete optimization to auto-optimize these prompts. And I'll be honest, that sounds like a made-up weapon from a sci-fi movie. How does an AI mathematically optimize its own English instructions?
Okay, let's break those terms down because it is brilliant once you see the mechanism. A loss function in traditional machine learning is basically a mathematical scorecard.
Okay.
It tells the system how wrong its current answer is compared to the perfect answer. Normally, you use this to adjust continuous numbers, like turning a volume dial from a 5 to a 5.2.
Got it. Smooth adjustments.
Right. But language is discrete. You can't use half the word. A word is either in the sentence or it isn't. So Adelflow uses discrete optimization.
Okay, how does that work in practice?
You give the framework a spreadsheet of, say, 500 examples of the exact behavior you want. Adelflow runs the agent, looks at where the agent failed, uses the loss function to mathematically score why the current prompt caused that failure, and then automatically rewrites its own instructions to fix it. It runs this loop thousands of times, testing, scoring, and rewriting until it hits the target.
Wait, but if we're entirely replacing human language with mathematical optimization, aren't we losing the whole point of large language models?
Now so.
Well, the dream was that anyone, even a non-coder, could program a computer just by talking to it in plain English. If we go back to discrete mathematics, aren't we shutting out the everyday user?
If we connect this to the bigger picture, it's actually the exact opposite.
Really?
Yeah. You aren't writing the math. The framework is. And we've seen this exact historical pattern before in traditional machine learning. A decade ago, there was this massive shift called the AutoML moment.
Oh, right.
Back then, data scientists spent most of their time handcrafting features for predictive algorithms. They were manually deciding which data points mattered. It was slow, it was fragile, and it relied entirely on human guesswork.
Sounds familiar.
Exactly.
Yeah.
Then AutoML came along and automated that feature engineering. The practitioners who adopted AutoML shipped faster, more accurate models. The ones who clung to manual tuning were left entirely behind.
So you're saying that prompt engineering is having its AutoML moment right now?
Precisely. We're transitioning from this mystical art of finding the perfect words to a data-driven engineering discipline. Any major AI agent framework that does not ship an automated prompt optimizer within the next year will simply be abandoned by developers.
The market mandate has been set.
Stop guessing what words work and start measuring the outcomes.
Okay, so let's pause and connect the dots here because this paints a pretty intense picture of the landscape. We've moved from brittle hand-typed demos to these highly optimized autonomous agents that are recursively improving their own instructions to take complex actions at scale.
It's an incredible amount of power.
It is, but it begs a massive question. What happens when these highly capable auto-optimized agents are actually deployed into the real world by, say, a Fortune 500 enterprise or the military?
That is the exact friction point where theoretical innovation violently meets real-world consequence.
Which brings us to the third and final article in our stack. The Pentagon is betting on agents before they're safe. Google is selling the insurance. And this piece has a detail that genuinely made me stop and reread the paragraph.
The supplier shortlist.
Yes. The US government just added a company called Reflection AI to its defense supplier shortlist for classified military AI operations. Now, they're sitting on this list alongside absolute legacy titans like Microsoft, Amazon, and NVIDIA.
Right.
But here's the kicker. Reflection AI hasn't even shipped a widely available commercial model yet. They are a relatively unknown entity.
The Department of Defense is clearly not waiting for the dust to settle, nor are they waiting for governance standards to fully mature. They're writing massive checks based entirely on the raw potential of agentic AI.
But hold on. If the Pentagon is buying pure agentic potential before the safety cages and governance structures are mature, aren't they basically buying a fleet of high-speed trains before anyone has laid down the physical tracks to keep them from derailing?
That's a very real concern.
Especially in a classified military context where, like, a hallucination could mean a geopolitical incident.
This raises an important question, and perhaps the most critical question of this entire technological wave. How do we definitively control what we're building? The authors of the article make it clear we're just impartial observers to the government's procurement strategies, but the market signal is undeniable. The demand for autonomous agents is vastly outstripping the infrastructure required to safely control them. And in the enterprise software world, where there's a massive governance gap, there's a massive market opportunity.
Enter Google.
Exactly. At their recent Google Cloud Next 26 event, they unveiled the Gemini Enterprise Agent platform. And what is so strategically brilliant about this release is that while all their marketing materials talk about autonomy and limitless potential, the actual system architecture they build is entirely about constraints.
Yes.
It's the tracks for the train. The source explicitly describes Google's product as the cage. They're taking agents and treating them like standard microservices. Because up until now, developers have treated agents like these glorified, omnipotent scripts that just run wild in the terminal, doing whatever they think is best.
Right.
But Google's platform enforces strict operational contracts. The article mentions they use state machines, mandated logging, approval thresholds, and policy as code. Can you explain what a state machine actually looks like in this context?
Sure. Think of a state machine like an old school vending machine. The machine has very strictly defined states. It's waiting for money, money has been inserted, or it's dispensing a snack.
You physically cannot force it to transition to the dispensing state unless the money inserted state has been mathematically validated.
Ah, I see.
Google is applying that rigid logic to AI agents. If an enterprise agent is in the drafting a vendor email state, it cannot transition to the sending email state without satisfying a specific hard-coded policy requirement.
Like a human manager clicking an approval button.
Exactly. It takes the flimsy ad hoc safety checks that developers have been duct taping together and replaces them with a native, mathematically verifiable control plane.
And the article gives us a fascinating real-world example of this in action with Remy. Remy is Google's internal staff-only personal agent inside the Gemini ecosystem.
Remy is a great case study.
Right, because Remy can book meetings across calendars, edit internal documents, send emails on behalf of the user, and the source points out something profound about how Google treats this internally. For Google engineers, Remy's real test isn't reasoning. The industry's basically solved reasoning. The models are smart enough to draft the email.
Yeah, that part is easy now.
The real test is authorization. How does Remy securely get permission to access your calendar? What structural mechanism stops Remy from accidentally hitting reply all to the entire company with your private meeting notes?
Remy essentially exists as a beta test to validate that governance layer before Google tries to sell it to a major bank or a national hospital network or the Department of Defense.
Because the stakes are just too high.
Because an autonomous agent without a highly functional, verifiable kill switch isn't a product, it's a catastrophic liability waiting to happen.
But Remy is entirely software. And the source makes a really sharp, crucial distinction here that I want to highlight before we wrap up. It contrasts software agents like Remy with what they call physical AI.
Right, moving into the real world.
We're talking about industrial robotics, autonomous drones, manufacturing arms on an assembly line. In the software world, if Remy hallucinates and makes a bad API call, the system logs it, a developer rolls back the bug, and maybe someone in accounting gets an annoying, incorrectly formatted email.
But when an autonomous agent operates in the physical world, a hallucination is a kinetic event. It's an immediate safety incident.
Exactly. If a physical agent misreads a visual sensor or misinterprets a prompt, a 2-ton robotic arm could swing into a human worker. The kill switch for a software agent is just a digital flag on a dashboard. But the source argues that the kill switch for a physical AI must be a literal analog hardware relay that physically severs the main power line.
Yeah, the digital cage, the state machine, it just isn't enough anymore when physics are involved.
It's totally different.
And this realization is causing the entire AI industry to violently bifurcate. On one side of the chasm, you have software agents operating with digital guardrails and policy as code. On the other side, you have physical agents requiring deeply integrated hardware cages. The gap between those two realities is the biggest unaddressed risk in the AI market today. The Department of Defense, healthcare providers, major financial institutions, they have realized the stakes. They will not buy a system, no matter how intelligent it is, if they cannot comprehensively audit its decision-making process and instantaneously shut it down.
It's a complete 180-degree flip from where we were just a year ago. A year ago, every company on Earth was racing to have the smartest, most creative foundational model. Now, intelligence is just table stakes. You can rent it by the hour.
Control is the new mode.
Wow.
The engineering teams that can mathematically prove their agents are bounded and controllable will win the massive high-leverage enterprise contracts that define the next decade. The teams that continue to treat safety and governance as a post-launch afterthought will just keep shipping shiny, useless prototypes into a vacuum.
So what does this all mean? If we look at the incredible journey we've taken through these three sources today, the narrative arc of the tech landscape is incredibly clear.
It really is.
We're watching the definitive end of the AI Wild West and the rapid beginning of the AI industrial revolution. We've moved from the frantic 6-week sprint to ditch the shiny Hollow Jupyter notebook demos and build real scalable infrastructure.
Yeah?
We've seen how flawed human intuition is actively being replaced by frameworks like Adelflow, treating our plain English prompts as auto-optimizing mathematical parameters just to survive the combinatorial explosion of complex agentic tasks.
Right.
And finally, we've seen how the ultimate value in this space, whether it's Google selling enterprise platforms or the Pentagon deploying classified systems, comes down to the leash. The tracks for the train, the kill switch.
The era of the magical demo is truly dead, and the era of the hardened, governed system is finally here.
Yeah.
But as we transition into this highly optimized, highly constrained future, there's a lingering thought that I think everyone listening needs to carry with them. If control is indeed the new mode, and if we are actively utilizing automated frameworks to recursively optimize our agent's logic far beyond the capacity of human intuition, who is actually writing the underlying rules for that final ultimate kill switch.
Oof, that is a genuinely chilling thought.
If the agent's prompts and behaviors are being optimized in ways we don't fully comprehend, utilizing discrete mathematics rather than plain English, will we even understand our own autonomous agents well enough to recognize when we are supposed to press that button?
It really makes you look differently at those movie set facades we talked about at the beginning, doesn't it? We're finally tearing down the sandbags, we're building real houses with real plumbing, real load-bearing walls, and real locks on the doors. We just have to make absolutely sure we are the ones holding the keys and not the house itself. Thank you for joining us on this deep dive. Keep questioning the systems being built around you, keep looking behind the facades, and we'll catch you next time. Imagine waking up, grabbing your coffee, logging into your AWS dashboard, and realizing a single automated debugging agent just racked up a $5,000 inference bill while you were sleeping.
Oh man, it's just a total nightmare scenario.
Right, like no warning, no approval, just this runaway loop burning through compute because, you know, it couldn't resolve a single test failure.
Yeah, and that's just the reality of the new economics of AI.
Exactly. So welcome to the deep dive. If you're managing an engineering team, architecting enterprise systems, or, just writing code today, the ground beneath your feet is shifting fast.
It really is.
Yeah.
We're looking at a fundamental realignment here, like the assumptions that govern the last decade of SaaS architecture, they just simply do not apply anymore.
Yeah, and our mission today is to explore 3 critical developments that are radically shifting the economics, the mechanics, and, well, the security of software development right now.
Right, because when you look at the mechanics of these events together, it's a very urgent narrative for anyone writing enterprise software.
Totally. So we're tracking 3 major stories this week. First, Cloudflare cut 1,100 jobs using AI, but its stock surprisingly crashed 24%, proving the market now rewards the builders of AI rather than the users cutting costs.
Which is wild to think about.
Yeah, it really is. Second, GitHub Copilot is killing flat rate pricing on June 1st, shifting developers to a per-token utility model that basically makes infinite AI loops a literal financial liability.
Pretty passive liability.
And third, Anthropic's new AI, Mythos, found thousands of zero-day vulnerabilities, prompting sheer panic at the Federal Reserve and basically forcing developers to automate their CI/CD security.
Yeah, the infrastructure we rely on is being repriced, and the security models we trust are they're obsolete.
Okay, let's unpack this, starting with the Cloudflare earnings call.
Yeah.
Because this completely upends how we traditionally value operational efficiency.
Oh, absolutely.
So they beat their revenue estimates, they beat their EPS estimates, then they proudly announced they were cutting 1,100 job support, ops, internal tooling all, because AI agents could do the work.
A massive win for efficiency on paper.
Right. And in any normal quarter, Wall Street rewards that kind of margin expansion with a huge rally. But instead, the stock plummeted 24% in a single day.
Yeah.
So wait, if a tech company builds a leaner machine with higher margins, shouldn't Wall Street cheer? It feels like replacing a leaky pipe, only to realize Wall Street thinks you're draining the whole reservoir.
That's a great way to put it. It really comes down to a brutal recalculation of the total addressable market, or the TAM.
Okay, the TAM.
Yeah. Wall Street isn't just looking at Cloudflare's quarterly balance sheet. They're looking at the foundational premise of enterprise software as a service.
Right.
Think about how almost all enterprise SaaS is priced today. It's inherently tied to human headcount.
Like seat licenses.
Exactly. You buy seat licenses for your support staff, your ops team, your developers. The entire valuation of the B2B software sector relies on companies hiring large teams of humans who need software to do their jobs.
Oh, wow. So if Cloudflare can suddenly automate 1,100 specialized roles using a handful of agents, they're basically proving that their own customers can do the exact same thing.
Precisely. If your customer base is about to shrink its operational headcount by, say, 20 or 30% over the next 2 years, I mean, who is buying all those enterprise seat licenses?
Nobody.
Right. A company celebrating massive AI-driven layoffs isn't just telling a story of efficiency. They're telegraphing that the legacy SaaS business model has a rapidly shrinking moat.
So the market looked at Cloudflare doing this and realized the broader B2B software ceiling is just caving in.
Yeah, building software to make human workers slightly more productive is now like, well, optimizing the aerodynamics of a horse-drawn carriage.
That's hilarious. But true, it's an impressive engineering feat, but it's applied to a dying paradigm, which really explains the massive divergence in where capital is flowing right now. I mean, we saw this $2 billion shadow from the Musk versus Altman trial revelation.
Oh yeah, the University of Michigan investment.
Right. They put $20 million into OpenAI back in 2019, and it's now worth roughly $2 billion. That's a 100x return.
It's staggering. You have to look at the leverage. Capital deployed into the creators of new factors of production, the AI builders is seeing exponential return.
While the users get hammered.
Right. Capital deployed into the traditional companies merely using those agents to optimize legacy workflows is getting a 24% haircut.
So the market is making a clear distinction here between tool builders and tool users.
Absolutely. So if you're a developer listening to this, the direct takeaway is that we are moving from software that helps humans do their jobs to software that replaces them entirely.
Wow.
The market doesn't reward the optimization of legacy SaaS anymore. It rewards the new factors of production.
So you have to be building the agentic workflow itself, not just the dashboard the human looks at.
That is the structural reality.
But, you know, the builders of AI agents are clearly capturing all the value right now. But what happens when those builders stop subsidizing the developers using their tools?
Things get very expensive, very fast.
Which leads us directly to our second article, and the sudden death of flat-rate AI pricing. Because on June 1st, 2026, GitHub Copilot switches to per-token billing.
Yeah, the era of the flat rate subscription is officially dead.
Right, the $10 to $20 all-you-can-eat buffet where developers could just hammer the API endlessly, it's gone.
It's a huge shift from traditional SaaS to utility computing.
Let's compare those financial risks, actually, because in traditional SaaS, the provider assumed all the risk of heavy usage, right?
Yeah, exactly. They abstracted the compute costs away, making the marginal cost of a query effectively zero for the developer.
So they were basically eating the compute costs to train the models on our workflow.
Yes, but now, thanks to much faster self-attention mechanisms crushing decoding latency, the underlying math has changed.
Meaning inference is cheaper.
It is cheaper to run, yeah, but that cost is now passed directly to you, the user. And power users, the ones who generate petabytes of completions in their IDEs, are going to see their bills absolutely spike.
While casual users might see them drop.
Right. It makes economic sense for the provider to sell compute as a raw utility now.
Here's where it gets really interesting, though. We've been coding at this all-you-can-eat buffet, and now it's a la carte. But doesn't this pricing model completely break the agentic workflows we've been building?
Oh, absolutely. The financial risk is severe.
Because, I mean, an agent looping 10 times now costs 10 times the tokens.
Exactly. A single advanced debugging session where an agent is recursively analyzing a code base can chew through 200,000 tokens in minutes.
That's terrifying, like that APRA anecdote.
The Australian Prudential Regulation Authority, yeah.
Yeah, they flagged AI agent governance as a control gap due to risk and reliability, but they completely missed the main threat.
The runaway inference costs.
Yes. An ungoverned agent is just a drain on the balance sheet. It's like leaving a jet engine on full throttle while parked on the tarmac.
That's a perfect analogy. Your first major AI governance crisis won't be a model making a biased decision. It's going to be a $5,000 overnight bill because a testing agent got stuck in a logic loop over the weekend.
So what's the direct developable takeaway here?
The hype cycle is ending with a metered bill. Developers must now map the value of a feature directly to its inference cost.
So we have to become our own actuaries, basically.
Pretty much. You need telemetry, hard caps on iteration loops, and local smaller models for trivial tasks.
Wow. But while an ungoverned agent might burn a hole in a developer's wallet, our third story shows how a highly capable agent pointed at software vulnerabilities could just burn down the entire ecosystem.
Yeah, the threat model here is exponentially worse.
We're talking about Anthropic's new AI, Mythos. The Fed actually had to get involved.
When the Federal Reserve gets involved in a vulnerability scanner, the paradigm has shifted.
Right. Mythos found thousands of zero-day vulnerabilities, kernel-level breaks, firmware flaws, across every major OS and browser. The Fed chair and Treasury Secretary actually called bank CEOs about it.
It's unprecedented. And if we connect this to the bigger picture, it changes the entire economics of offensive security.
How so?
Well, historically, an elite human researcher might find, 1 0-day a month. It's manual, painstaking work.
You can only hold so much state in your head at once.
Exactly. But Mythos operates with massive parallel execution. It found thousands. And with a 6 to 12-month retrain cycle, the vulnerability pool is only growing.
Because it learns from its successful exploits.
Yes. The new threat model is no longer increased risk. It's total vulnerability.
So what does this all mean for the pipeline? I mean, if attackers are using an automated machine gun like Mythos, we can't still be defending our code bases with a musket, right?
Oh, no, you absolutely can't.
How do developers actually fight back without stopping deployment entirely?
This is where CI/CD integration becomes critical. You have to fight automation with automation. Have you seen tools like the Fixer?
Like Intruder.
Yeah, exactly. Intruder. Think about a manual pen test. It costs $10,000 to $50,000, takes weeks, and by the time you get the report, the architecture has already changed.
It's totally reactionary.
Right, but Intruder is an AI that scans, exploits chain vulnerabilities, and generates remediation reports in minutes.
It actually generates the remediation code.
Yes, it doesn't just block the build, it applies the patch and it opens a pull request for the human to review.
Wow. So the direct takeaway for our technical audience is that AI in CI/CD is no longer optional.
Security is now the main bottleneck in software development.
So if developers are shipping software without an AI-driven security feedback loop integrated directly into their CI/CD pipeline, they're essentially building sandcastles in a hurricane.
That's exactly what they're doing. And the market reality backs this up completely.
Oh, totally. I mean, look at the hard market data. Akamai just locked down a $1.8 billion cloud deal with Anthropic.
Right, which gave Akamai stock its best day in 22 years.
22 years. Meanwhile, you look at consumer tech, and Google is launching a $99 AI health coach, while Whoop bets on human doctors.
Consumer markets are split on AI versus humans.
Exactly, proving the massive divergence in market strategies. But in enterprise security, the market is unanimous. AI ingestion of the code base is the only path forward.
Human-driven security is dead. It's an infrastructure arms race now.
It really is. Okay, let's summarize this deep dive for you, the listener. As a software developer today, your enterprise mode is shrinking, your unlimited coding buffet just got metered, and your security pipeline requires an immediate AI overhaul to survive automated zero-day hunting.
It's a completely new landscape.
Yeah.
And it leaves us with one final, I think, very provocative thought to mull over.
Go for it.
If an AI model like Mythos is finding your bugs, and an AI model like Intruder is writing the remediation code, and you are just paying per token for the privilege of letting them talk to each other, at what point does the underlying code base belong more to the models than to the engineers? And how exactly do you value a human developer in a purely token-driven economy?
That is a chilling question to leave you with as you look at your own repositories tomorrow morning. Thank you so much for joining us on this deep dive. Map your token costs, automate your security pipelines, and we'll catch you next time.
Welcome to the n0brains podcast. We have 4 exciting articles to talk about today because, well, while you were sleeping last night, an AI agent with its own cryptographic bank account basically debated 3 other bots about global inflation,
Right.
reached a consensus, and then executed a massive multi-million-dollar trade. And it did all of this without a single human being clicking a button.
It's completely wild.
It is.
Yeah.
So today, we are doing a deep dive into 4 recent dispatches from n0brains. And what we're doing is decoding a market that's, violently splitting into two distinct speeds.
Yeah, totally.
On one side, you've got these giant legacy institutions deliberately rebalancing billions of dollars using these massive, slow-moving data pipelines. And then on the other side...
You have autonomous AI swarms just trading in milliseconds.
Exactly.
And the goal for our deep dive today is to really understand the actual mechanics of this split. We aren't just going to read the headlines to you.
No, we're looking under the hood.
Right. We want to uncover how you, listening right now, can actually fuse these massive institutional data signals with an understanding of automated execution to find your own edge. Because frankly, the game has completely changed from even just a year ago.
Oh, without a doubt. So let's start with the slow and massive side of the equation, right? The great institutional rotation.
Yeah,
Because the numbers in these dispatches are just staggering.
they really are.
Like, take Jane Street. They're widely considered one of the smartest quantitative trading firms on the planet. They just slashed their Bitcoin ETF holdings by 81%.
It was a massive cut.
Massive. But at the exact same time, they're quietly but very aggressively ramping up their Ether funds. And it's not just nimble hedge funds doing this. Wells Fargo, which is a $2 trillion legacy American bank.
Fourth largest in the country, actually.
Right. They made the exact same pivot in their Q1 13F filing.
Yeah, and for anyone wondering, a 13F is basically just a mandatory quarterly report. Any institutional manager with over $100 million has to file it. It forces them to open their books to the public.
Show everyone what they're holding.
Exactly. U.S. equities and now crypto ETFs. So when you see a massive rotation showing up on a 13F from a bank like Wells Fargo, it signals a fundamental regime change in how digital assets are treated. They're looking at crypto as a diversified sector now, not just a monolithic gamble.
Okay, let's unpack this because to me, this institutional movement is a lot like a giant cargo ship trying to turn around in a small harbor.
Oh, I like that.
Right, because they can't just hit the brakes or, yank the steering wheel. If Wells Fargo or Jane Street decides to dump $1 billion of Bitcoin at market price, they just capsize their own trade,
Yeah, the sheer size of the order would eat through all the available buyers.
causing the price to plummet before their order even finishes executing, which is what we call slippage. So to avoid that, they use TWAP algorithms, time-weighted average price.
To slice it up.
Exactly. They slice that massive billion-dollar order into tiny, invisible fractions and just bleed it out into the market slowly over weeks or months.
Right. And if we connect this to the bigger picture, the cargo ship metaphor perfectly explains the how, but we really need to look at the why.
Why rotate from Bitcoin to Ether?
Exactly. And it comes down to structural baggage versus real yield. Ether actually offers real yield. So if you hold the asset and stake it to secure the network, you're paid a continuous dividend.
Kind of like a digital bond.
Exactly like a digital bond. But Bitcoin, on the other hand, is currently just burdened by this old guard infrastructure. The companies that mine Bitcoin are bleeding cash right now.
Get bad.
Look at the n0brains sources on traditional mining companies. Banked, which was supposed to be this pristine institutional gateway, just posted a 77% revenue drop.
Wow.
Yeah, and they're desperately pivoting to stablecoins just to survive.
And the CleanSpark numbers in that report honestly blew my mind. They lost $378 million in a single quarter.
Insane.
I mean, that is a staggering loss for a company whose only job is to run computers to mine digital gold,
Right, but the hidden layer there is what that massive loss actually does to the market. Because CleanSpark and these other miners, they have enormous electricity bills. So when they operate at a almost $400 million deficit,
They'd have to sell.
they have to sell almost every single Bitcoin they mine just to keep the lights on. And this creates what traders call overhead supply.
Oh, got it.
It's a constant, invisible sell wall that just suppresses the spot market price of Bitcoin. So when the risk managers at Wells Fargo look at all this, they see Bitcoin weighed down by failing miners, and they see Ether sitting there with a clean runway and a built-in yield.
Makes total sense.
Yeah.
But I think it's crucial we emphasize to you listening, this does not mean capital is fleeing the digital asset space entirely. It's just maturing.
Very true.
The earnings data from eToro, which is a huge retail trading platform, totally backs this up. Their net income jumped 37%, mostly driven by commodities, while the crypto trading volume dropped 32%. So the retail frenzy has definitely cooled.
It has. But at the same time, historical probability models still give Bitcoin a 77% chance of hitting a new all-time high within a year.
Really? Still that high?
Yeah. So the smart money isn't all in or all out anymore. They're managing spreads, durations, and narratives. That massive rebalancing signal from a $2 trillion bank using TWAP algorithms, that ripples through the order books for months.
Which naturally leads us to the next puzzle. If these legacy institutions are rotating billions, they need a physical path to move that capital, right?
Yeah.
They can't just rely on Western OTC desks. They have to build the plumbing.
The infrastructure.
Exactly, like Hana Financial. There's this massive banking group in South Korea, and they just paid $668 million for a 6.55% stake in Dynamo.
Which operates the Upbit exchange.
Right.
And mathematically, a $668 million check for that percentage values that single exchange at over $10 billion. That is a fortress valuation.
It is. And this isn't retail money just testing the waters, you know. This is a direct institutional pipeline being constructed. So Korean won can flow seamlessly into digital assets.
Yeah.
That's a legacy bank deciding the regulatory friction of the past few years is basically in the rear-view mirror. They want a permanent seat at the table.
But we have to contrast that, right? That pristine billion-dollar banking pipeline versus the reality of the decentralized rails themselves.
Yeah.
Because the market is in this chaotic superposition.
Oh, the Thorchain thing.
Yes. On the exact same day that Hana Financial drops almost $700 million to build their bridge, Thorchain, a decentralized network, suffers a $10 million exploit and has to completely pause trading.
It's the ultimate crypto whiplash.
Yeah.
You've got billions in legacy valuation on one hand and a hacked frozen liquidity router the other.
Right.
But let's break down why a protocol halting actually matters.
Sure.
Because a $10 million loss isn't going to wreck the global financial system on its own.
No, it's the pause itself that's the problem. It creates what we call a synthetic supply shock.
How so?
Well, Thorchain acts as a massive cross-chain bridge. It lets people swap native Bitcoin for native Ethereum without a middleman. So when they halt the protocol, the bridge is barricaded.
Right.
Arbitrageurs, the traders who buy cheap on one exchange and sell high on another to keep global prices balanced, they literally can't do their jobs. So these pools of money become isolated.
And the immediate result of that closed bridge is severe slippage for the everyday user. Because if you go to a decentralized exchange to swap tokens while the main routers are down, the automated market maker penalizes you.
Big time.
You might try to trade $100 and only get $85 worth of tokens back because the liquidity pool is completely disconnected from the broader market. It's just a massive structural drag.
And it directly contradicts that bullish institutional pipeline we just talked about. Banks are pouring capital in to move billions, but the decentralized rails are still incredibly fragile.
Right. And just to add a third layer to this chaos, we saw Hyperliquid's HYPE token surge 23% in a single day, driven entirely by a local catalyst.
Oh yeah, an ETF filing and a Coinbase partnership.
Exactly. So what does this mean for the listener trying to navigate this? It shows us that macro downtrends, or even infrastructural fears, they don't matter if the local catalyst is strong enough.
They really don't.
You have a bank buying in, a protocol getting hacked, and a token ripping 23% higher, all at the exact same moment.
Which proves the old correlation models are dying. You can't just look at the S&P 500 and assume crypto will follow. You have to distinguish between the macro tide and the local wave.
So we've outlined the friction. Trillion-dollar institutions forcing capital through decentralized bridges that sometimes snap. But here's where it gets really interesting.
Okay.
The entities trading on these rails at the highest frequencies, they do not care about the friction because they aren't human.
Right.
While the banks are filing 13F paperwork, AI infrastructure just took a huge leap forward.
Yeah.
A platform called Buy402 just gave AI agents batch settlement wallets.
This is huge. Up until this development, AI agents were basically brilliant brains locked in a jar. They could analyze charts, read Twitter, generate these sophisticated trading signals, but they couldn't act on them. A private key still required a human being to physically click approve on an extension.
The AI was the analyst, but you were still the executioner.
Right. But batch settlement changes the whole architecture. It creates a smart contract vault where the AI is pre-authorized to execute specific logic loops. No human signature needed for every microtransaction.
Wow.
A swarm of AI bots can now operate as a single economic entity. They share data sets, execute split-second arbitrage when a bridge like Thorchain goes down, and most importantly, they can pay their own overhead.
That is the wildest part to me. If an AI bot needs access to a premium live data pipe like a WebSocket feed, it can authorize a fraction of its own trading profits, convert it to Ethereum, and pay the network fee for its next trade.
It's autonomous.
It has a bank account that speaks its native protocol.
Yeah, and if we look at the Agentic Ada research paper from the sources, it highlights the stark contrast between traditional algorithms and these new AI swarms.
Yeah, I like to think of traditional algorithmic trading bots as deterministic toasters.
Toaster.
Yeah, because a toaster only does one thing. You push the lever down, the coils get hot. It doesn't care if you put in bread, a frozen waffle, or a piece of cardboard. It just heats up.
All right.
A traditional algorithmic bot sees a moving average cross on a chart, and it fires a buy order blindly. It's incredibly fast, but it's totally rigid. So when the market regime flips, like a surprise inflation report hitting while liquidity is draining, that toaster is going to burn your money.
It extrapolates a broken pattern and just fails.
Yeah.
But the agentic HIDA framework introduces a completely different mechanism. Instead of one single logic loop, it spawns a veritable debate club of specialized agents.
Wow.
Yeah, so you have one AI model purely dedicated to scanning Twitter for sentiment.
Wow.
Another model monitors cross-chain money flows, watching whale wallets. A third tracks the macroeconomic calendar. And before a trade executes, they literally argue.
Digital debate club running at light speed.
Exactly. They weigh contradicting data. The sentiment model might scream buy because of a trending hashtag, but the macro model vetoes it because it knows a Fed announcement is 10 minutes away. They reach a mathematical consensus score before touching the execution vault.
It gives them a frontal cortex.
It really does. It allows them to adapt to complex shifts.
Okay, I am extremely skeptical of this. Let me push back.
Sure, go for it.
An AI debate club sounds amazing on paper, but financial markets are fundamentally driven by irrational human panic, right? How can a purely logical AI swarm price in the fact that a tech CEO just tweeted something totally unhinged at 2 a.m.? Doesn't a logical AI just get run over by human unpredictability?
It's a good question.
I mean, if the AI is spending compute power debating a stale rumor on a Telegram channel, is that just highly sophisticated garbage?
Well, what's fascinating here is that is the exact vulnerability researchers are trying to solve. You just highlighted the true bottleneck in modern automated finance.
The data.
Exactly. The bottleneck isn't execution speed anymore. We solved that. The bottleneck is data ingestion. You cannot debate what you do not see. Garbage in, garbage out, no matter how many virtual PhDs your AI swarm has.
So if your sentiment agent misses that 2 a.m. tweet, the debate is operating on a false reality.
Precisely. If your macro agent is working with a delayed CPI print, the consumer price index, the consensus is worthless. The edge is no longer in having the smartest algorithm. It's in having the cleanest, fastest, most cross-referenced data pipeline.
Okay, so what does this all mean for the listener? How do you actually survive in a market where legacy institutions hide massive trades and TWAP algorithms, and AI debate clubs are front-running the news?
You don't need a supercomputer in your garage.
Right, but you do need to upgrade your mental models. You have to fuse the signals. You can't just trade off an isolated headline anymore.
Fusing the signals means looking at structural data before reacting to noise. When you see a bullish headline, your reflex must be to cross-reference it. Look at the volume deltas, the difference between buying and selling pressure.
Are the aggressors actually backing it up with real cash?
Exactly. You look at the TVL total value lock to see if money is actually sitting in the smart contracts, or if the decentralized bridges are closed.
And the sources show how fractured the current market context really is. We have data showing Bitcoin facing heavy resistance just below $82,000. But depending on the time frame you look at, data also shows it comfortably range-bound around $105,000.
The time frame changes the entire reality.
Right. And simultaneously, DeFi TVL is ticking up, showing money entering, while overall market sentiment remains super cautious. In an environment this complex, the market brutally punishes confusion.
And it heavily rewards clarity. If your strategy is a single deterministic equation, if you're still operating that toaster, you are the exact prey these multi-agent AI swarms are hunting.
I mean, the machines are already running the show at the institutional level anyway. The sources note that Binance, the largest crypto exchange in the world, just blocked $10.53 billion in fraud using AI agents.
10 billion! Let that sink in.
Think about the mechanics. The AI is analyzing thousands of behavioral data points simultaneously. How fast a user's mouse moves, IP routing history, the exact second a wallet connects. It's processing anomalies a human compliance officer could never spot in real time.
And the gap between spotting a fundamental signal and executing a trade has shrunk to absolute zero.
So, to summarize the map of the territory we've explored today, we are officially operating in a two-speed market. On the macro layer, the giants are turning the cargo ships. Institutions like Wells Fargo and Hana Financial are slowly hedging their bets, rotating into real yield assets like Ether, and buying up Asian infrastructure pipelines.
And on the micro layer, autonomous AI agent swarms are getting smart contract wallets, paying their own fees, and using debate-style logic to transact in milliseconds, which honestly leaves us with a rather profound and somewhat unsettling implication to consider.
Uh-oh.
Well, we know these multi-agent systems require pristine, cross-reference data to debate effectively, right? The consensus is only as good as the evidence they ingest. But as these AI swarms become the dominant market participants, a new vulnerability emerges. What happens when a highly advanced swarm figures out that the most profitable trade isn't actually debating the data,
Right.
but deliberately polluting the data pipelines to trigger false consensuses and rival AI agents?
Oh, wow.
Yeah. Are we moving from a market of financial speculation to a market of automated psychological warfare?
Wow. Now, that is a terrifying and entirely plausible thought to leave off on, because if the bots learn how to bluff each other by faking on-chain data or spamming sentiment feeds, the game changes entirely.
The human element of irrationality replaced by an artificial element of deception.
Man. Well, we want to thank you for joining us on this deep dive. Keep questioning the signals around you, keep looking for the structural data behind the headlines, and remember, whether it's a legacy bank hiding $1 billion rotation or a swarm of AI agents debating at the speed of light, it's all just data waiting to be decoded. We'll catch you next time. You know, if you look back centuries ago, cartographers used to actually draw sea monsters on the edges of maps, right, where they just didn't have any data. Literally, they would just write, "Here be dragons."
Right, because, I mean, the unknown is naturally terrifying to us. When human beings encounter these massive blank spaces in our understanding, we just tend to fill them with monsters. Or, you know, looking at modern financial markets, we fill those blank spaces with just panic and a whole lot of noise.
Exactly. And for the longest time, trading in financial markets was, well, it was essentially navigating with those old parchment maps. You had a few fixed landmarks, a lot of human intuition, and just a terrifying amount of blank space.
Yeah, a lot of guessing.
Right. But then we got the algorithmic equivalent of GPS, right? We got the quants, the high-frequency trading firms, the supercomputers, and the map suddenly got filled in.
Yeah, but I mean, it got filled in so densely that it actually created an entirely new hazard. We sort of transitioned from this severe lack of data to such an overwhelming just a deluge of information that the map itself practically became unreadable to the naked eye.
Unreadable, and that is exactly why we are here. So welcome to the deep dive. For you listening today, our mission is to cut straight through that unreadable map. We are taking a stack of recent market intelligence reports and some research from a platform called n0brains, dated mid-May 2026.
Right.
And we are unpacking how artificial intelligence is just fundamentally rewiring financial markets from the absolute ground up.
Yeah, we are basically dissecting a complete structural shift here. We are looking at, you know, the autonomous algorithms actually executing the trades, the physical energy infrastructure powering this totally new grid, and the tokenized networks that are attempting to coordinate all this machine intelligence.
So whether you are, you know, a seasoned trader prepping your portfolio for the next quarter, or you're just insanely curious about where high finance collides with artificial intelligence, we are giving you the shortcut today.
The rules have officially changed. I mean, finding an edge in the market is just, it's no longer about being the fastest coder in the room anymore.
Right.
It is entirely about having the clearest data.
So let's start right where the action is, which is the algorithms that are actively trading on the front lines right now.
Yeah, the landscape of automated trading has shifted just dramatically away from human input. And the primary example in our research stack here is a new AI framework called MetaEvolve.
Okay, let's unpack this.
Yeah.
Because when I first looked at the documentation on MetaEvolve, you know, it read like a science fiction novel.
Oh, absolutely.
This is a framework built by researchers who are essentially taking DeepMind's AlphaEvolve methods, and they are applying them directly to the financial markets.
Yeah, and to really understand the leap here, you have to think about the traditional bottleneck in algorithmic trading, which is, well, the human being.
Right, us.
Exactly. Historically, building an automated strategy required a quantitative analyst to, you know, sit down, write the code, back-test it against a bunch of historical data, tweak the risk parameters, and then they had to manually update it whenever the market regime shifted.
Which takes time.
A lot of time. MetaEvolve completely removes the human from that optimization loop. Completely. It uses a large language model, an LLM, to actually generate its own trading rule sets, test them in simulated environments, and then continuously mutate them on the fly.
So it's generating and mutating its own rules without human supervision at all.
Right.
So, sort of visualize this for the listener. Building a trading strategy used to be like handcrafting a bespoke engine. You had a master mechanic carefully machining every single part, adjusting the timing belt by hand, testing the horsepower.
Yeah, a very artisanal process.
Exactly. But now, frameworks like LLMs, are just running an automated assembly line.
Yeah.
They're churning out these high-performance engines way faster than a human could even audit the code.
And that assembly line allows a trading system to adapt to market volatility almost instantly, right? It generates thousands of iterations just to find the optimal path through the data.
Wait, I have to push back on this premise just a bit.
Okay.
Because if the LLM optimizer is essentially becoming this open source template, if any well-funded firm can just spin up an automated assembly line that prints these perfect engines, doesn't the engine itself kind of stop being the competitive advantage?
That is a great point.
Right. If everyone on the track has a super engine, doesn't winning the race just eventually come down to the quality of the fuel you put in it?
What's fascinating here is that your skepticism highlights the exact paradigm shift that this n0brains research really focuses on. The researchers refer to this trap as garbage in, ghosts out.
Garbage in, ghosts out. I like that.
Yeah, because an LLM, no matter how computationally advanced or highly evolved it is, it cannot conjure accurate market context out of thin air.
Right, it's an engine.
Yeah.
It doesn't actually know the layout of the track unless you actively feed it the map.
Precisely the issue. If you take this highly evolved, mutating strategy and you feed it raw or delayed or noisy market data, it doesn't just miraculously make profitable trades.
It just fails faster.
Exactly. It simply executes a losing strategy with blinding speed. A sophisticated optimization loop running on a bad market indicator still produces a bad trade. Therefore, the true moat for a trader is just no longer the algorithm itself. The optimizer is becoming a commodity. The moat is the signal pipeline.
The fuel?
Fuel. The architecture of the future isn't an LLM trading in some isolated vacuum. It requires a highly curated, cross-referenced signal feed. It needs what the researchers actually call fused signal.
Use signals. Let's break that down for the listener. Meaning, observing a single event in isolation is essentially useless. A system needs to automatically connect disparate dots. For example, it needs to instantly recognize if, say, a massive transfer of Bitcoin by a single large holder, a whale.
Yeah, a whale transfer.
Right, if that whale transfer coincides with a major shift in the macroeconomic calendar.
Exactly. Or, connecting that large whale movement to a sudden spike in funding rates.
Okay, explain funding rates briefly.
Funding rates are essentially the premium that traders pay to keep highly leveraged positions open. So if those rates spike right before, say, major inflation data is printed by the government, the market is severely unbalanced.
Okay, so fusing those three disparate data points, the on-chain whale movement, the derivatives funding rate, and the macro calendar, that requires infrastructure most traders simply do not possess.
Not at all. The automated algorithm is the variable, but the pristine fused signal, that is the constant requirement.
But building that pipeline, that isn't just a software problem, is it? Running mutating LLMs and processing all this fused real-time data, that is a massive physics problem.
Oh, absolutely.
It requires an unbelievable amount of electricity and hardware, which kind of forces us to look at the physical world, the infrastructure pivot.
Yeah, because software inevitably crashes into the limits of hardware. And the Bernstein research in our stack details this massive physical transformation happening in real time, focusing specifically on Bitcoin miners.
Which is wild, because when most people think of Bitcoin miners, the image is just these giant warehouses packed with computers aggressively guessing math problems just to win daily block rewards.
Right. It's viewed as an industry fundamentally tethered to the daily price chart of Bitcoin.
Yeah.
But Bernstein's analysis reframes that entire thesis. The reality on the ground is that miners are no longer just competing for cryptocurrency block rewards. They are rapidly becoming the most critical suppliers of physical infrastructure for the broader AI industry.
Because they have the power contracts.
Yeah.
Literally, they have the electricity.
They do. Bitcoin miners control massive allocations of cheap, high capacity, and often stranded energy. They have the transformers, they have the substations, and the massive grid connections already built out.
Right.
And the AI industry, which is facing an absolute explosion in training demands, is desperate for that exact electrical capacity.
Let's dig into the mechanical reality of this, though, because a Bitcoin miner can't just run an LLM on their existing hardware, right?
No, not at all.
Mining uses ASICs, which are these highly specialized single-purpose microchips that basically only know how to mine Bitcoin. but AI requires massive clusters of GPUs.
Right, and that hardware swap is the heavy lifting of this entire pivot. These companies are physically ripping out rows and rows of ASICs, they're upgrading their cooling systems to handle much denser heat loads, and they are installing cutting-edge GPU clusters.
Wow.
Yeah, they are leveraging their hardest-to-acquire asset, which is the power grid connection, to pivot their business model entirely.
I understand the theory there, but I mean, I'm looking at the market context provided in the sources for mid-May 2026. Bitcoin is stuck under $77,000. U.S. bond yields are hovering near 20-year highs, which is draining risk appetite and capital across the board.
It's a tough environment.
The daily charts are just screaming caution. So my question is, if these miners are sitting on such a goldmine of energy and AI compute capacity, why is the broader market still treating them like basic commodity plays? I mean, why aren't their stocks flying high like traditional tech infrastructure?
That pricing divergence is exactly where the actual trade is hiding. You have to learn to separate the macro weather from the structural climate.
Okay, the weather versus the climate.
Right. The broader market right now is pricing these miners based on the daily weather. You know, the price of Bitcoin dropping, high bond yields, tight capital. It's a storm. But the AI infrastructure tailwind, that is a permanent climate shift.
So the market is staring at the rain today and completely ignoring the tectonic plates moving underneath the entire industry.
Exactly. Just consider how Wall Street values a company. When a public mining firm relies solely on the price of Bitcoin, it is valued as a volatile commodity stock. Its revenues fluctuate wildly from month to month.
Sure.
But the moment that same miner physically installs those GPUs and signs a multi-year AI hosting contract, its underlying business fundamentals change entirely. It secures predictable, recurring revenue.
Oh, wow.
Yeah, Wall Street then transitions its valuation from a low mining multiple to a significantly higher data center landlord multiple.
That is a massive re-rating.
Yeah.
Because a data center landlord with locked-in multi-year contracts is a completely different beast to institutional investors than a pure crypto miner.
Precisely. Private infrastructure markets are already pricing these facilities as data centers, but the public retail market is still reacting to them as purely Bitcoin-correlated stocks.
Right.
The gap between those two realities is your edge. The actionable intelligence here isn't obsessing over Bitcoin's daily fluctuations, it's identifying the re-rating catalyst. It's finding the exact moment a miner secures an AI deal and shifts its identity.
Here's where it gets really interesting now. Because we've mapped out the AI software generating the strategies, and we've talked about the physical data centers powering them. But what about the coordination layer?
The token.
The actual crypto tokens? Because, I mean, history shows that whenever a new technology booms, you just get an absolute flood of tokens trying to capitalize on the hype. And the sources actually describe the current AI crypto sector as a vaporware graveyard.
Vaporware is unfortunately the most accurate descriptor for the bulk of the market right now. The research notes that the sector is just littered with basic API wrappers, which is essentially just slapping a new user interface on existing tech.
Right.
And simple chatbot demos that are heavily marketed as revolutionary decentralized infrastructure.
It's like seeing a flashy, big-budget movie trailer that promises the greatest sci-fi epic of our generation, right? But then when you buy a ticket and you walk into the theater, the screen is just blank. There's literally no movie.
Exactly. It's just founders pitching tokenomics slide decks promising the world while delivering zero actual network usage.
And the market exhaustion there is just palpable. Token valuations eventually collapse because the narrative vastly outpaces any measurable on-chain utility.
Yeah.
However, the n0brains data provides a stark counterexample here, where real verifiable on-chain structure is actually forming. And that is a network token called REPPO.
Yeah, and the Nansen deep red data on REPPO is incredibly specific. It tracks 136.6 million tokens currently locked inside a smart contract called Repo.
Right.
And that single contract holds 13.65% of the entire circulating supply. Over a recent 30-day window, the net amount of locked tokens actually grew by 2.1 million.
Wow.
They also track wallet behavior over a week, showing 1,630 distinct buys versus 1,539 sells. So that is a clear mathematical accumulation bias.
See, this is the critical difference between just a marketing narrative and measurable on-chain reality. REPO is actually attempting to build the functional coordination layer for all this intelligence, and that V prefix you mentioned, Repo, that is vital. It stands for vote escrowed.
Right. let's make sure that's clear for the listener. What does a vote escrowed contract actually do to the tokens?
Well, it means users are intentionally locking their tokens up for a set period. So they are completely giving up their ability to sell them quickly.
Right.
And in exchange for that illiquidity, they gain voting power and influence over the network's reward emissions. They're essentially posting financial collateral.
Now, I'm going to play devil's advocate here because we see these fleeting trends in crypto constantly.
Sure do.
People will lock up tokens temporarily just to farm a new airdrop or to scrape a quick artificially high yield. And the second the rewards drop, they just unlock and dump everything.
Yep.
So how do we know this 13.65% locked supply isn't just a temporary mercenary farm?
The defense against that assumption really lies in the wallet behavior analysis. The blockchain ledger shows repeat staking behavior across multiple wallets. So users aren't just locking once, right? They are acquiring more and continuously locking it. That pattern indicates sustained conviction in the network's mechanism, rather than just a hit-and-run yield farm.
But wait, isn't repeat staking also exactly what a sophisticated mercenary farm bot would be programmed to do, just to compound its yield automatically? Why does this point to actual human conviction?
That is the exact right level of skepticism. And to answer it, we have to look at what the collateral is actually doing. The core thesis of REPPO is building a marketplace where human signal is staked and evaluated.
Oh, okay.
When users lock tokens, they're backing the quality of data streams. If they feed the network garbage data, their locked stake gets mathematically slashed as a penalty.
Oh, wow.
Yeah, it's a built-in financial mechanism that violently punishes bad actors and rewards human accuracy. And those autonomous AI agents we talked about earlier, the ones running Madevolve, they come to this exact marketplace to consume verifiable intelligence.
I see. So instead of just launching an isolated AI agent and hoping retail investors gamble on it, they're building the underlying marketplace where AI agents purchase their own fuel, the curated data, and the signals.
Exactly, that is the architecture. But, to remain completely impartial here, we really must highlight the structural risks the sources clearly outline. Because the system is not immune to gravity.
No system is.
Concentration is a major vulnerability.
Right.
The top wallets still control a very disproportionate share of the supply. Furthermore, the research flags specific distributor flows linked to an entity known as virtuals, which remain a significant pressure point hanging over the market.
Yeah, that is the sword hanging over the chart, right? If those early whales or major distributors decide to cash out and flood the market, the brilliant underlying technology won't act as a parachute.
No, it won't.
The price will still tank, so you have to monitor that distribution pressure constantly.
You do. But the broader takeaway from the n0brains research is that REPO serves as the new template. The speculative era is ending. The market is violently shifting toward rewarding networks with measurable throughput, verifiable collateral, and actual machine usage.
Which really brings all these disparate threads into the ultimate stress test. We have LLM agents mutating their own code, we've got energy companies physically ripping out hardware to become data centers, and tokens building collateralized data marketplaces.
Right.
But all of this is unfolding in mid-May 2026 against a macroeconomic backdrop that feels incredibly hostile.
Yeah, the macro reality is unforgiving.
Yeah,
It simply does not care about how revolutionary your AI infrastructure is.
not at all. The sources paint a picture of a market being practically ripped apart by conflicting forces. On the bearish side, you have Bitcoin dropping abruptly to $76,000 overnight as geopolitical tensions involving Iran escalated. And of course, keeping things strictly analytical, regardless of the political dynamics there, the market reaction is intense volatility. You have what the analysts call a Satoshi-era miner, someone who has held Bitcoin since the network's earliest days, waking up and sending $203 million in Bitcoin to over-the-counter desks.
And just to clarify for everyone listening, an over-the-counter or OTC desk is essentially a private off-grid market. Massive players use OTC desks to sell huge blocks of assets to institutional buyers without instantly crashing the public exchange prices.
Right.
But the sheer volume signals intent to exit.
Exactly, the kind of quiet pressure that spooks traders. Analysts are actually warning that if underlying buying support evaporates, the market could slide rapidly down to $72,000.
Wow.
Further compounding this, general on-chain demand metrics are faltering, and total value locked in decentralized finance, DeFi, DeFi is cooling off significantly.
Right, so geopolitics violently shaking out over-leveraged positions combined with legacy whales distributing assets. I mean, that is a textbook macro storm. It creates an environment of extreme downward pressure.
But then you look at the data from the exact same 24-hour period, and the bullish signals are staggering.
Yeah, they really are.
Michael Saylor's corporate strategy just dumped another $2 billion into Bitcoin.
Wait, 2 billion more?
Yes, bringing their total treasury holdings to an incredible 843,738 Bitcoin.
Unbelievable.
Additionally, the derivatives data shows intense short positioning by traders who are betting on the price to fall. This means if there is a sudden geopolitical de-escalation, say an Iran peace deal, we could see a massive short squeeze.
Where all those negative bets are forced to buy back in.
Exactly, rocketing the price straight toward $80,000.
It is the absolute definition of a dual headwind. You have terrifying macro volatility bearing down on one side and the persistent noise of AI vaporware distracting from the other.
Yeah.
So what does this all mean? If you are listening to this right now, how are you supposed to manage risk in a market that features a $200 million Satoshi-era dump on Tuesday and a $2 billion institutional corporate buy on Wednesday?
If we connect this to the bigger picture, the central thesis from these intelligence reports is that single-threaded analysis completely fails in this environment.
Single-threaded meaning relying on just one metric or one narrative.
Right. A singular focus is fatal right now. You cannot just stare at the daily closing price of an asset or exclusively read geopolitical headlines and expect to maintain an edge. The sheer cognitive load is just too high.
It's impossible.
A human being cannot simultaneously track the macroeconomic calendar, the geopolitical flare-ups, the on-chain OTC flows of ancient whales, the specific voting behavior of Verepa wallets, and the corporate physical upgrades of Bitcoin miners.
Because the map is entirely covered in noise. It's unreadable.
This is precisely the environment that makes automated scored directional signals the new mandatory baseline. You require systems capable of ingesting all of that disparate data, the macro, the on-chain, the social sentiment, the corporate actions, and fusing it into a single synthesized output that offers actual direction and timing.
Because while the LLM algorithms are constantly mutating just to survive the market volatility, the pristine fused data is the only thing that actually provides them with a true north compass.
Exactly. Filtering relentlessly for on-chain reality and demanding high-quality synthesized data streams is your only viable defense against getting completely torn apart in a multivariable environment.
So for you listening, the ultimate takeaway from this deep dive is a fundamental structural shift in how you should approach trading and investing. Stop trying to write the perfect static strategy.
Right.
Stop trying to handcraft the engine. The machines have already beaten you to it. Your goal, whether you are managing a personal portfolio or prepping the strategy for an institutional desk, is to focus your entire bandwidth on finding or feeding the perfect signal.
The signal pipeline is the new competitive mode. The optimization engine is merely a commodity.
It's a complete inversion of how the financial industry used to think about trading. But before we wrap up today, I want to leave you with a thought to mull over, building on all the realities we've just unpacked from this stack of research.
Let's hear it.
We are rapidly transitioning into a future where large language models are independently writing and mutating the actual trading algorithms.
Yes.
The entities consuming the market intelligence and data aren't human analysts anymore. They are autonomous AI agents.
Right.
And the underlying physical computing power, the data centers that used to mine crypto, well, that is being driven primarily by the sheer machine demand for more compute rather than human financial speculation. So the coordination layer, the execution layer, and the physical infrastructure are all fundamentally transitioning to machine intelligence.
It creates an entirely closed, self-sustaining loop of machine commerce.
Yes. So the provocative question is this. If the machines are writing the rules, executing the trades in milliseconds, and powering the underlying electrical grid, well, what does the future role of the human trader actually look like? Are we just the ones making sure the data pipeline stays clean? Are human beings destined to become just the janitors for the AI's fuel supply?
That is a brilliant and, frankly, a slightly terrifying question to end on. It forces every listener to reconsider where human intuition actually retains its value in a fully automated financial ecosystem.
We used to draw sea monsters on the edges of the maps because we didn't have enough data. Now we have so much data that the machines are drawing the maps for us in real time. We just have to make sure they're using the right ink. Thank you so much for joining us on this deep dive. We'll catch you next time as we keep cutting through the noise.
The voltage shadows grow. A million voices trapped in a single frame. A burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know. Where the bits break down and the shadows grow. Shadowed out. Total set. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. A million voices trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadowed out. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. A million voices trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive. Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadow now. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadows grow. A million voices trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadowed out. Total set. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. A million voices trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadow now. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. A million voices trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadowed out. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. A million voices trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Hold the line. Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadow now. Flicker in the corner of my sight, another phantom bleeding into white. I'm tracing lines that weren't there before, a hollow knock upon a silicon door. The voltage climbs, the air begins to sting. I'm losing count of every broken thing. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. A million voices trapped in a single frame, a burning circuit with a secret name. We're chasing echoes of a dying sun before the final sequence is begun.
System error. Hold the line. Red light, dead light.
Tell me I'm alive.
Red light, dead light.
Help me to survive. Give me the ghost inside the machine, the coldest spark that I've ever seen. Velocity is the only truth I know, where the bits break down and the shadows grow. Shadow now.